From MCJ, I'm Cody Sims, and this is MCJ's Startup Series. Today, our guest is Erica Nemser, CEO at Ardent. Ardent is a Series A stage startup that's aiming to help drive industrial decarbonization by developing and selling membranes to perform point source carbon capture. Point source capture differs from direct air capture in that it's focused on concentrated greenhouse gas emissions coming right out of the flue of an industrial system, as opposed to direct air capture, or DAC, which attempts to capture emissions from ambient air. Ardent, as Erica explains, has been around for about 30 years as a company and was formerly known as Compact Membrane Systems. Their focus on carbon capture and repositioning as a scalable technology startup is relatively new. Erica and I talk about the company's focus on point source capture and how Ardent Solutions differs from other point source capture technologies, how different industries, sectors, and geographies are approaching the problem, and how her leadership style has helped the company navigate a significant transformation. But before we start, I'm Cody Sims.
I'm Yin Lu.
And I'm Jason Jacobs, and welcome to My Climate Journey.
This show is a growing body of knowledge focused on climate change and potential solutions.
In this podcast, we traverse disciplines, industries, and opinions to better understand and make sense of the formidable problem of climate change and all the ways people like you and I can help. Erica, welcome to the show.
Thanks for having me.
Erica, let's dive in. I'm going to start with an off-the-top question, which is you just rebranded your company. You are now Ardent, which is, of course, how we'll describe you in the pod, but that wasn't the name when I first got to know you guys. So maybe share a little bit more about what caused the new change in name and positioning.
Sure. Now we're Ardent. We were previously Compact Membrane Systems, and Ardent just reflects really our complete focus on decarbonization and climate technology. So we're ardently moving forward into the decarbonized world.
Well, there we go. Was Compact Membrane Systems less focused particularly on decarbonization technologies and was more of a membrane manufacturing company? Like, help me understand that change.
Sure. Compact Membrane Systems had existed for 30 years. Its focus was tough chemical separations, and we continue to do tough chemical separations. Obviously, we're going to talk about carbon capture, and that's one of them, but the company's history was developing new technologies across a range of applications and delivering membrane systems into those. So we do, in fact, have membrane manufacturing and industrial facilities.
But the new Ardent is purely a brand shift. Like, the company is still a 30-year-old company. Is that correct?
That's correct. Brand shift and very significant focus on carbon capture.
And how did you land on that as being where you wanted to take the business going forward? 30 years is a long legacy for a technology company.
Absolutely. So I came 10 years ago when the technology team was really focused on a novel membrane separation technology. So the game-changing, out of the lab, doing fundamental basic research that we associate with startups. And this novel technology could be used in a number of places. And one of the places that's a fantastic match between the technology attributes and the application needs is carbon capture. So we started developing and focusing in that direction. And I'd say the market has really come to meet us there, which is great.
I come at things from a climate tech perspective, less a traditional energy perspective. When I think of membrane technologies right now, I mostly hear in the context of hydrogen electrolyzers. How similar or different is what you are manufacturing and building compared to technologies that are used for PEM electrolyzers, for example?
I'd say somewhat similar and somewhat different. We're more similar to the large-scale separation technologies that are used, that people may be familiar with actually from water desalination or from gas separations, like separating oxygen and nitrogen, which is a big industrial application. And those are industrialized, they're trusted, they're used around the world. They are often on a per ton basis, which is what's important when you want to talk about carbon capture, and on an energy consumption basis, relatively high consumers of energy and kind of expensive on a per ton basis. And that's okay, because when we drink water and we want to do water desalination, each of us doesn't consume a ton of water. When you want to shift and look at something like carbon capture, where you're decarbonizing. We're talking about industrial carbon capture, which is mainly focused on industrial flue gases that are part of the emissions profile of the hard to abate sectors that are responsible for about a third of global CO2 emissions. Those are big, big, big streams. And so you need a novel membrane technology that can do some of those big streams, but can also offer solutions to tough challenges in much smaller streams and be productized to do those.
For the first 25-ish years of the business, what were the separations that you mostly focused on? Are we talking petrochemical plastics and things like that?
A lot of dewatering and gas separating out of organic material. So one that people may think of is we're deployed on a lot of electrical transformers. And so we're just pulling the gases out of a typical electrical transformer. And the value proposition that offers is basically grid reliance. Because when electrical transformers fail, if they do that unpredictably, then that can take big pieces of the grid down. But by doing this gas extraction and analysis, you're able to predict if there's going to be a transformer failure and take action before that happens. And so we've been in the field of energy for a really long time.
These are in like substations? Is that where you would be deployed?
Yeah,
there?
in power gen, exactly.
Okay, interesting. But mostly around natural gas power gen?
In the electrical transformer, so it could be in a variety of different power gen, but those tend to be natural gas,
okay,
yeah.
Interesting. So you said this is a 30-year-old company. You joined, and then as you've come into it, you've ultimately now shifted the business toward carbon capture. And you said the market is now meeting you to where you shifted it. Walk us through that pathway. How did you, A, decide to join this company in the first place? And then what was the process of ultimately shifting the priority focus of the business?
Sure. So my background is all on the business side. And within that, working with companies who are developing new technologies that have a long development cycle, and you're bound by what chemistry or science will do. So I was an economist by training. I went to management consulting, and then I came here to lead Ardent.
13 years at McKinsey, like you have a serious pedigree in management consulting. Don't sell yourself short there.
Yeah, and it was really an enjoyable time. And I learned a ton that was really valuable and applicable here to Ardent. So the couple of things, as I said, is what does commercial development look like and pre-commercial development look like of a science-based technology? And how do you use partnerships in order to bring something new to scale? And that's really relevant here. And it's a couple of partnerships. One is obviously Ardent and other small and startup companies are really great at innovation and development because we can do that innovation separated from the quarter by quarter pressure that large Fortune 500 companies face, and separated from basically the need to protect an incumbent technology. We don't face that innovator's dilemma that if we put something really new in the market, we could cannibalize our existing products. And so that's a lot of what the value proposition of startups are. When you look at where that partners to scale, if you have to build scale yourself and do everything in-house, that's often not super efficient. You want to take advantage of other core competencies, and that's where you partner for scale. And that's very relevant in carbon capture because it's such a nascent market on the infrastructure side, on the market side, that everyone's trying to make a move to this, and being able to partner with others who bring a lot, whether that's midstream, and by that I mean the transportation of CO2 or the ability to build large infrastructure projects. We're great at membranes and we're great at membrane manufacturing. And it really does make sense to partner with others.
And going from management consulting to, at the time, compact membrane systems and now Ardent, how did you make that jump? You had a global role at McKinsey and you're working into a fairly, what at the time sounds like niche energy technology company.
So I think most management consultants ultimately leave management consulting to go into industry and to make the world a better place in the way that they see that. I likewise wanted an operating role. The things that I have always enjoyed are difficult business problems. That's the thing that I took from my background as an economist. Give me an interesting market that's got a tough challenge. And I really enjoy things that seem impossible, but if you structure them and look at them in the right way, you can turn impossible to merely challenging and merely challenging into doable. And this was one of those places where I could have a lot of impact with the capabilities and the background that I brought. into a space where when I came to climate 10 years ago, remember it was clean tech 1.0 was sort of in its bust era. People said this was going to really take a long time to come back. And a lot of what I saw when I looked at the space is not a shortage of great technology, but what you saw was maybe less partnering of great technology and technologists with business thinking on how do you build a business in this particular space, in a science-driven space where you can't always pivot yourself out of every challenge, right? Unlike a digital space, you're like, okay, the business is this, and I can imagine it being something else, and I can just move there. You're bound by what in our case, chemistry and other things are going to do. And so that's where I had a lot of background, but business thinking really is very valuable in thinking through some of those problems.
It does sound, though, like you took the hardware and the chemistry expertise that the company has and pivoted the go-to-market focus. So you maybe didn't change the underlying guts and bones of the company, but you put a whole new wrapper around it.
We definitely put a whole new wrap around it. I mean, it's an amazing technology team and it's an amazing technology. When I came, though, they had a new technology platform and they had about 20 different programs. So that's a little bit of a mindset of lottery tickets, meaning any of these could win. So the more I have, the better. And the market will come, the build a better mousetrap thing, right? Like if I have great technology, people are going to show up. That's not so true.
Sounds a lot like from Walter Isaacson's Steve Jobs profile of his second coming at Apple, where he took all these product lines and like whacked them down to a few.
Exactly. And so we started to ask ourselves questions and do portfolio rationalization. And this is where the McKinsey background was really helpful because I did 8 or 10 different McKinsey projects all at once. There's portfolio rationalization. There's organizational culture. At the end of the day, yes, it's a technology company, but it's a team and culture company because the technology is not going to build itself, the people do. And so really understanding what that culture look like, as well as what are the capabilities, how do we test new things in the market? How do we understand customers and get more customer insights that look like things, putting engineers on phone calls with customers for the first times in their lives and saying, learn something.
Did you have a hypothesis that carbon capture was where you thought the company might be able to go when you came in?
We had a hypothesis around facilitated transport membranes, which is the platform that carbon capture is. We first deployed facilitated transport membranes actually within the chemicals industry in olefin and paraffin separation, which is the workhorse separation of the chemicals industry to basically have them be able to produce with a lower CO2 emissions footprint and higher productivity. So it's an efficiency play there. And carbon capture was the next extension to that. And frankly, that part of that is because when I talked to people 5, 6, 7 years ago about carbon capture for industry, and I thought, hey, this is a fantastic match between our technology profile and the market need. They're like, that's 40 years away. Nobody wanted to partner, pilot, et cetera. That's completely changed.
So let's dive into that side of things then, which is the core of what you do now. When you say carbon capture for industry, are you mostly talking about decarbonizing the heat process that industry needs? Or are you talking about decarbonizing the end chemical process of producing whatever material it is that they produce?
Sure. I mean, it's a lot. It's all of those. In general, if you look at the big categories of where's decarbonizing, using carbon capture most relevant, it's in the places where you have locked in emissions, meaning you have a piece of equipment that you are using either because it needs high temperature heat or it's running some other process, but that thing has a 30, 40, 50 year useful life, and just the carbon emissions and cost of throwing that away and putting some new thing in would be really high. So how do you bolt something onto that to do CO2 emissions? And it tends to be also places where the CO2 emissions are embedded in the production of the thing, meaning it's not just the combustion for heat that we think of with sort of typically boilers, but things like steel production and cement production that emit CO2 in addition to that. But there are thousands of different applications, some enormous, like the ones I mentioned, some smaller that are all looking at, well, how do I not throw this thing away? How do I capture the CO2 as a part of my decarbonization journey, recognizing in 30, 40, or 50 years, I'll be using some new equipment that's cooler and better, but that future isn't here yet. So how do I make an alternative future available to me?
Let's take cement, for example. These percentages I'm sure are not right, but I think of cement emissions, CO2 emissions, as being roughly half due to the need to use coal to get to temperature, and roughly half due to the actual chemical reaction of creating cement. And so it sounds like your technology could work on either side of that.
On either side of that. They want the high temperature heat to run the kiln, and then within the kiln, they're emitting CO2. So both of those are challenges, right? Within the kiln, you're in the production itself, you're going to emit CO2. You need to go after that. And high temperature heat's not so easy to electrify. So how do we go and capture CO2 there? And I'll add another one when you think about cement is how do we do that within the practical confines, and this is where membranes are really relevant, of a cement plant. So if you think about cement's not typically shipped all over the world. It's produced locally. It's used within a couple 100 miles of where it's produced. They're often in close proximity to where people live, and they don't have a chemicals profile on sophisticated utilities, meaning they don't have a lot of chemicals emissions. They're not looking to make CO2 capture either complicated or more dangerous than their plant is now. And so because membranes essentially function like filter cartridges, they're very appealing to that. And so that's an important part of practical CO2 capture. It's not just the cost point. If you think about emitters and plants being able to put carbon capture in place, but it's the practical things of, will it fit inside my plant? Does it not use a lot of energy because I can't actually get that much more energy from the grid, et cetera?
I mean, that second question is the one I hear the most as being a problem with industrial carbon capture, which is this notion of what's called the energy penalty, I think, which is that in order to actually release the CO2 once it's captured, you have to, in most technologies, I think amines, liquid amines being the most typical one, you actually have to heat it up. And so you're stealing energy that would otherwise go to power the plant to then heat up your carbon capture system to release the CO2 and put it somewhere. And I've heard order of anywhere from 20 to 40% sort of energy loss running these systems. I don't know if that's anywhere accurate, but some kind of semblance of a significant amount of energy loss.
Exactly. And so part of the practical reality that our customers come to us with is how much does it cost, but also what's the energy demand on the system? And that's exactly their concern. One, energy is costly. Like we all know that we pay for energy, right? The world is trying to move to decarbonize energy. So the more energy you consume, the more pressure you put on that system. And then the last one is they just can't access a lot. So even if energy were plentiful and free, there's still going to be a limit. As one of our steel partners said, Erica, we've looked at all these other technologies, and even if those technologies were free, if they demand a nuclear power plant quantity of energy, we can't deploy them because we're not going to do that, and that's not available. And so these membranes solve that problem for customers.
So do they not then require significant amounts of heat or energy to release what has been captured in them?
Correct. So a membrane works in a continuous flow process. So you mentioned amines, which is you have to absorb it and desorb it. So you've got to run a process that embeds the CO2 and then releases it, which uses energy. The membranes work in a continuous process, so there's no similar release of the CO2. They're just flowing the flue gas stream. Flue gas is mostly nitrogen, which is a component of air, so that can be released to the atmosphere, and the CO2, which can be sequestered. So what you want to do with membranes, run that continuously and run it at low pressure, because we all have compressors on our air conditioners. We know those consume energy, they cost money. So the smaller that system can be, and just being able to run it with a low pressure like a blower, like your hairdryer, right? Or a very low pressure means we don't require that level of energy. And the big innovation in the membranes was something that could do a lot of CO2 capture in a really small membrane system at low pressure.
And if that's the case, I assume if you're not having to integrate deeply in with the energy system of a plant, does the retrofit component of getting into the plant also become easier because you're not having to plug into how they generate or use power?
We'll have to plug into their energy, right? We will need some energy to run the system, even if it's just a blower. It's not demanding a lot. And so what that means, it's not competing with a whole set of other decarbonization plans that they have. If you think of like a cement plant, we talked about, it's pretty simple. If you think of a steel plant, it's more complicated. A steel plant's the size of a city. It's square kilometers. You drive around it. It's got hundreds of streams. So when they want to decarbonize, they have plans. They have hundreds of different projects that they're going to do. And so you want to be one that doesn't demand so much energy to be able to do them.
Describe what your system looks like.
Sure. So our system is a membrane module. It looks like a filter cartridge. It's about the size of a scuba tank. And the way that you deliver those to a customer is to just rack them up and put them in a shipping container and make a standardized product. So you can deliver that to whether it's a cement plant or steel or another type of application, and they can hook that into their unit operation. So you're just going to grab the flue gas into that. You're going to release the nitrogen out of that shipping container, and you're going to create a sequestration stream of CO2 out of it.
How different is this from other separation scrubbers that have been mandated by industrial facilities in the past, whether it's prevention of acid rain, et cetera?
So I'd say there's two similarities. There's the technical and then there's the economic. I would say we all now have absorbed the costs, and I'd say quite successfully, of the Clean Air Act and the Clean Water Act for the 70s. Those demanded changes to emissions. And so there are scrubbers that capture other emissions and wash it away out of the stream so it's not released into the air. We have them in our cars. Catalytic converters do that so that we don't release materials into the atmosphere that we don't want. And we actually bear those costs, and they're reasonable costs, right? When we go to buy a car, half the cost of the car is not a catalytic converter, right? It's in the hundreds of dollars. And so this aspires to do the same thing, which is how can we continue to have the materials that we want, whether they're steel, whether they're cement, and especially as the global south expands and its production of those things in order to meet its growth goals, that we not constrain the ability to continue to use the materials that have fueled development like steel and cement for a long time, but to do that cost effectively.
Hey everyone, I'm Yin, a partner at MCJ Collective, here to take a quick minute to tell you about our MCJ membership community, which was born out of a collective thirst for peer-to-peer learning and doing that goes beyond just listening to the podcast. We started in 2019 and have grown to thousands of members globally. Each week, we're inspired by people who join with different backgrounds and points of view. What we all share is a deep curiosity to learn and a bias to action around ways to accelerate solutions to climate change. Some awesome initiatives have come out of the community. A number of founding teams have met, several nonprofits have been established, and a bunch of hiring has been done. Many early-stage investments have been made, as well as ongoing events and programming, like monthly Women in Climate meetups, idea jam sessions for early-stage founders, climate book club, art workshops, and more. Whether you've been in the climate space for a while or just embarking on your journey, having a community to support you is important. If you want to learn more, head over to mcjcollective.com and click on the Members tab at the top. Thanks, and enjoy the rest of the show.
And so we've talked about these industrial use cases like steel and cement. One of the critiques of point source carbon capture is that you can prolong the life of fossil fuels. And in your case, I would think in particular, given what you've described, you could just say, hey, let's just keep burning coal forever and we can throw these things on them and everything will be great. I'd love to hear your thoughts and feedback on that.
Sure. I'd say most people have already realized that coal, except in rare cases, is not economical. And so we don't see coal walking through our door as a solution that we need to solve. I'd say generically, the solution may be high temperature heat, but that tends to be natural gas. And so what we look at is how do you decarbonize those things such as natural gas? But if we take it one step further, it comes back to that locked in emissions, embedded infrastructure piece, which means it's not that factory or facility loves fossil fuels. It's that they love the piece of infrastructure that they have in place that's making whatever widgets that they make.
And that they've already paid for.
And it's there and it's going to last another 40 years and it happens to use fossil fuels. I'm not hearing from a lot of people that they're committed to the fossil fuels. They're committed to a low-cost, great solution for themselves. And when that thing retires in 30 years, they're totally open to a solution that's an alternative. And so I'm trying to meet my customers where they are, which is they're going to keep using those fossil fuels on that piece of infrastructure. How do we offer them a solution today?
There are some who would propose that we're in a current transition point where the world is going to have to decide what systems we go for, particularly around heat, which is driving a lot of industrial emissions. Do we end up in a world where we continue to have fossil fuels with carbon capture that requires the build out of CO2 pipelines and CO2 storage wells and all of that kind of broad, almost pseudo-public infrastructure that needs to get built to support that? Or do we end up in a world where we leapfrog that and eventually thermal batteries and electric heat win the day? I'm curious, is it an either or thing? Like, is the world going to align on one solution, or do you see there being a smorgasbord of different solutions out there for the foreseeable future?
I'm in the smorgasbord camp. I'm definitely in the yes and. And the analogy I'll give you is transportation, which is also a system. And so if you rewound 100 years ago and you ask, so is it going to be a car system or a bike system or a train system or a bus system or a light rail? What do we have? We have yes and. We have all of those systems depending on what the needs of the users are and what the most efficient infrastructure solution is. And a little bit of policy obviously plays a role in that. Different regions in the world have different solutions to relatively similar problems. And the same thing's going to play out here, I think, which is people will gravitate to low-cost, easy solutions. So if you can provide those, they will move.
Do you think that carbon capture solutions for industry will get adopted more quickly in areas that already have local infrastructure like CO2 injection wells?
100%. I think there's two sides to what needs to happen. One is on our side as a membrane company, but anyone who's offering technology solutions, is we have to offer something that has a strong value proposition, is low cost, is easy to use, is productized. Meaning we're not asking our customers to build elaborate products. We're not coming to them and saying, I have an engine, cars are great. You say, I have a motor, it's in a car by the car, right? So we need to be able to deliver those easy solutions. The first places that they'll be deployed are places where, as you said, infrastructure is end to end and the CO2 can be valorized in some way. Either the regulatory framework creates enough of incentive to them, or there's value from the CO2 itself. Those will be the first markets that turn. Those will then create the infrastructure and the momentum for the larger applications in bigger markets to expand, like every market has ever been in the history of markets, with my economist hat on there.
From a geo perspective, I mean, in the US, you have very different environments just in the US, right? You've got a market like Texas that maybe has a lot of local infrastructure for this sort of thing. And then you have other markets that maybe do not. And then you have, from a global perspective, different geographies that are using carrot approaches like the US with a bunch of tax rebates. And you have markets like Europe that are using stick approaches, which is creating taxes and penalties for emissions. Where are you seeing market interest today?
Well, in three, there's another one which fits more in the European model, which is Canada. And you absolutely see customers respond to those and responding the way that you would expect to market conditions. They will chase dollars and they will chase penalties and they will make realistic decisions around those. So for example, I'll give you a case. You can read about our deployments in Europe. Okay, so we have a pilot plant in a steel facility. We have a pilot plant in a refractory materials, that's a kiln process, and one in a boiler system in oil and gas, actually. And who actually want to use to ultimately, right, they can be sequestration partners because they have subsurface assets. In all of these, they look at the regime they're in, they can pencil stuff out and do the Excel on how much should I capture? Can I pilot something early that captures half my stream, and as technology advances, could go get the second half when further penalties and costs accrue to me, and they are making logical decisions. So we absolutely see multiple regimes of policy having an impact on decision making at the customer basis. But as you described, infrastructure has its role to play, and this is really a nascent market. And the analogy I'll give to that is Netflix. Now everyone's familiar. They watch Netflix, streams onto their device of choice. Netflix's original business model, I don't know if people remember this, is they mailed DVDs around to you because streaming wasn't able to support the business model of delivering the content in that way originally. And so they started developing the customer base in one way and expanding. It's the same here.
You mentioned the oil and gas side of your business, and it prompted me to think that Oil and gas has been pretty acquisitive in the carbon capture realm. I think oil and gas companies drive a lot of the point source capture business today that's active. I believe Schlumberger bought a point source company fairly recently for multiple $100 million. Oxy bought Carbon Engineering, which is a direct air capture company. So it's a little bit different, but why are oil and gas companies leaning into carbon capture so aggressively?
So I'd say over the last 5 years, I've seen oil and gas companies really move their thinking and reflect that in the way that they are organized as businesses into the creation of something typically called the new energies business. And this is all about sequestration of CO2. Because if you look at the assets that they have, both the physical assets as well as where are their capabilities and core competencies, they're great at doing large projects, having large systems engineered geology, and they have assets underground like depleted oil wells that are great sequestration sites. And so they are looking at this as a way to utilize that as part of the decarbonization journey that we are all on. And I think something that goes unrecognized by many, but again, with my old economist hat on that you see is this is a fantastic area to take advantage of somebody who's committed and moving and has assets that it would take the world 30 years to build it another way. If they can deploy those now, that's to everyone's advantage. And secondly, it doesn't compete with their old business. It can stand aside. So if anyone's familiar with The Innovator's Dilemma, and Clay Christensen, the premise there is it's so hard for large companies to innovate because they worry about destroying their existing business. And so they hem and they haw, they move slowly, they struggle. And that's where disruptive startups come in and take over. If you look at decarbonization writ large, that takes a lot of physical infrastructure. So if startups have to do that alone, it's really rough. And so the advantage of these big companies not competing with their conventional business, that's right, everyone said we hit peak oil and now we're past it. They can be successful with CO2 capture and it's fine in terms of any impact on their traditional business and traditional mindset. That's really unique.
And presumably they know how to monetize the shoulder parts of this business, which is pipelines and wells and all. Like they know how to build financial products around that. They know how to build businesses in those areas.
Exactly. And where you're leading us to is something that the industry calls carbon capture as a service. And that's essentially thinking of a party that's an emitter like a steel plant or a cement plant wants to get rid of their CO2, but doesn't want to do that in a complex way. They want to treat it the way they treat their other utilities, like water that they purchase, energy that they purchase, or waste that they have picked up. They want it to be simple and they want someone else to manage the whole process. And so if you want to do carbon capture as a service, which is essentially carbon capture waste pickup, you need a big organization like that doing sequestration and pipeline, et cetera, to be able to put all that together.
So I'm hearing you say the energy companies can go from currently just being a fuel provider to these industrial facilities to now being a fuel provider and a waste removal partner, essentially, and providing that service. So that's sort of oil and gas's angle at leaning into this and expanding their business model to include this new product line. It sounds like the industrial companies, though, are coming at it from a different angle, which is they just need license to operate. Like they need to be able to operate in a world that is increasingly demanding their continued product at a low cost, but with lower emissions going forward.
Exactly. And that comes back to the question that you asked about how is this similar to the world where we had the Clean Air and Clean Water Act, that we still want those products. They need to find a way to deliver the products they deliver today, but modified so that they don't have CO2 emissions.
So it sounds like many of these projects, whether you're getting involved or not, are going to have multiple actors involved. There's a steel plant that is buying its energy to run its plant from somewhere. It's got multiple other partners dealing with its various waste streams. Obviously, it's got its own supply chain for selling its product that it goes into. For you coming into these environments to do business, these can be incredibly complex financial engagements. They can be incredibly complex infrastructure engagements. How are you approaching this from a business perspective? Are you licensing technology to some other project developer? Are you coming in and developing a new project on site inside an existing factory? Are you mostly looking at greenfield, new factories as they're getting built? How have you approached the go-to-market?
So this is where our 30-year-old history really helps us in terms of entering the market and building partnerships so that we play to our core competencies, which are manufacturing and delivering membrane modules, and partnering with others that can open up markets. And so the way that we look at this is for initial applications, you want to design once, cut 1,000 times standard product. So we work with a fabricator who can fabricate that and often is embedded in that industry, whether it's ag or midstream or something else, and we're delivering membrane modules into that. And for us, from a business standpoint, those are membrane modules that have a discrete lifetime. So there's a replacement cycle that's still economically attractive for the customer, but builds a business for us. And then we become a critical partner to those folks serving the industries they serve now in new ways. And then you mentioned oil and gas. If they're doing sequestration, we're critical upstream technology that enables those solutions.
So I'm hearing largely a fairly traditional product development, product sales company. You're not having to get involved in complex project finance or complex licensing type of business models. Am I following correctly?
You are following correctly. At least to start, that's a great business model for a company. It's capital light. It puts money to the top line and to the bottom line. It served us and others in similar industries really well. And I'm not ruling out those other business models. I'm just saying as a place to start, you want to start, land and expand, right? And that's a great place to land.
And so who mostly then takes you on site? Who is buying your solution and then getting you implemented on a plant?
Well, I would say it's early days in this ecosystem. So while we look at over time, we'll have more of those partnerships delivering. We have a discrete number now, and you'll see those hit press releases and things hit in the future. But we do a lot of our own business development now, because just think about what that product adoption curve looks like. We're all talking about the early adopters and then being able to move in with some of those fabricators and others into a broader set of applications.
How drop-in is the solution? You mentioned it looks like a shipping container with a bunch of oxygen tank-like things. Is it requiring a huge amount of retrofit for the current facility to implement you?
It's not a huge amount of retrofit. So ideally, we're not demanding any different utilities than they have. And so they need a pad to land the thing and they need the traditional hookups. And so when we've done that with our partner facilities for a demonstration plant, you're talking about something that fits in the existing construct of the way they run the plant.
And so far, any sectors that are particularly biting, saying like, yeah, move faster, Erica, bring us this stuff?
Agriculture is one that's, because coming back to your point about being able to use the CO2, they generate CO2 now from bio-based boilers and other processes. They can use the CO2 in greenhouses and they can put their excess CO2 on the market to others. And so that's a really nice end-to-end solution.
Which particular ag processes, just to make sure I'm following?
So they do need heat and other things. So they're generating that heat using bio-based fuels, right? So they're combusting, and combustion produces the CO2 just like in any other combustion process. Because plants like CO2, and in ag, if you have a greenhouse, you want to increase the CO2 concentration inside that greenhouse and then have those plants be more productive because they have a higher level of CO2 around them. And then you're kind of sequestering within those plants. And so vegetative plants versus a manufacturing plant.
Interesting. And so they're using you as essentially a closed loop system. They'll capture the CO2 on the combustion and then they'll use it for more efficient greenhouse growing.
Exactly.
And that's in a world where there isn't a lot of carbon CO2 sequestration infrastructure globally yet to take the CO2 that you're capturing and actually store it somewhere.
Exactly.
Erica, what else should we cover? What have I not hit on that you think is important that we make sure to talk about?
The question I often get is, how do I think about and should I think about jumping in to either climate or I have a CO2 company or I have a CO2 idea? And what should I do? I would say from everything that we've discussed, the thing that we've taken away that's been most valuable is actually the parallel development of the customer base. And we just talked about one in agriculture with the technology. I'd say we started this conversation on what drew me here and what was I bringing to the table. And I think that same story of how do you take great technology, but bring some business thinking so that you're not pivoting a million times, you're really quick out of the gate, is really that. How do you develop that customer set, really understand what customers want, what that product is, and use that in your development process?
I mean, you had a built-in advantage where you already had a bunch of live customers you could start doing customer discovery and customer development with. If you're a founder starting from scratch today, how would you start?
I'd start with get to your prototype and start having those conversations. I mean, you are right. This singular, most defining differentiator we have on that side is we are already an industrial company. We already manufacture and ship thousands of membrane modules, so we are trusted to deliver product. I cannot express how valuable that is when you want to play in an industrial space. And so getting to that point and having partnerships, if not you, with someone else who can do that for you is crucial.
On that note, you fairly recently raised a Series A round of financing for a 30-year-old company. Tell us what that experience was like going from essentially a steady business to, hey, we're going to convince people now that we can scale as a venture scale company.
Sure. Part of when I came and sort of pivoted the company and reoriented to where we're going was, hey, we're aiming at building billion-dollar businesses and in trillion-dollar markets. And so that's venture scale, and you build that a different way. And venture's the natural place to support the growth of that kind of business. We definitely are pioneering a new mode of what's the profile of a venture company look like, that we have that kind of approach, but we are an ensemble cast of people who are newly out of school with people who have a lot of industrial experience, et cetera, which makes us a really powerful team, right? I have people on my leadership team in their 20s, 30s, 40s, 50s, 60s, and we're an amazing group together, but we are definitely a different picture than two recent Stanford grads who are trying to build a business. And so there was convincing folks that that model worked. It was actually not hard to convince industry. So the Series A investors included 4 strategics. And for those, some of them were customers already. And they were definitely bought into this model can work because we know how to engage you as an industrial company. I would say venture, it was a little bit more of a journey.
How do you make decisions internally when someone is proposing either a solution that might cannibalize existing revenue that you have that is no longer strategic to the company, or proposing a redirection of resources from something that you have that is an operating line of business, but that you know that talent internally could be put to use on something that's more aligned with the future of where the company's going? Like these trade-offs, most startups don't have to make these kinds of trade-offs at your stage. These are like big company level trade-offs typically.
Absolutely. I mean, and you see the big company level impact, right? So you can't do everything, right? Focus is true for us like it is for every startup. So one of the questions we ask ourselves is, where are the contracts and the work that we can do in our traditional business that it doesn't take business building, business development, et cetera, that it can run as part of the manufacturing plant? And that's where being an OEM player with long-term contracts is really helpful. So manufacturing continues to manufacture those, and then we can use that manufacturing equipment for this new stuff. And then the questions that you're asking is often, okay, well, if we wanted to go into this other business, how much impact would it have on carbon capture? Is it synergistic? Does it build in some way? Or are you just offering another line? And if it's another line to a $50 million business, that's probably not worth doing. So we try to cast it in that way. And that's kind of akin to what every startup has, or at least every materials technology company. They tend to have, I could use it in these 50 different places and I've got to pick something.
So I'm hearing there are huge benefits in that you have existing product, existing manufacturing capability, existing revenue that presumably you can use for things like debt facilities and whatnot as you need it. But where you simply have to be very focused as a leader is not allowing essentially smaller incremental businesses to try to grow and expand in ways that are small and incremental. How do you help direct resource toward things that have exponential growth potential.
Absolutely. And that was a mindset shift for the organization.
Tell us, what are some of the exercises you worked with people on to drive that mindset shift?
So one was running people through what will it take for this to be successful and really pushing on that and having people walk through, well, do we have those people? What would it take? So really, for technologists in particular who love their technology, helping them see that. And then I would say, secondly, what's the likelihood of success and do we control it? So one of the big mindset shifts was, and you really see this in carbon capture too, if we do everything right, will we win? Or does something out in the world have to happen that we don't control in order to enable success? And if you need that other thing to happen and we can't control it, that's probably not the best bet to take.
How much is success exogenous to you completely versus in your own control, I'm hearing you say. And then I'm also hearing you say, how many sort of unvalidated assumptions does this product line sit on top of?
Exactly. And so the way that we talk for the mathy people, it's the nested if statement. If, and you got 5 ifs to happen to win, that's not as great as one.
And yet I heard you started off the whole conversation saying carbon capture is a market that has caught up to you. So you took a leap of faith there somewhere early on.
Right. And that's why we started our deployment, that the platform is deployed in chemicals, and then CO2 is the extension. That was a big leap of faith, but we had confidence that the necessity of that was going to happen and it was going to move in that direction. And if it was just chemicals, that's still an enormous business.
Erica, where's the company based? Where are you looking for talent? What kind of help do you need?
Sure. We're global. We are based on the East Coast is where our research and manufacturing facilities sit. We have staff in Europe. We have a team in Houston. And we are looking for talent across the board. So we are looking for VP of engineering roles. We've got always chemical engineers, mechanical engineers, commercial roles, et cetera. So if you think you have something to offer, I'm open to having a conversation, whether we've got an open role for it or not. Because at the end of the day, it's the people that are going to make the technology work, not the technology itself. So that's always a focus.
Erica, really appreciate you joining today, sharing more about what you're building, and I enjoyed learning from you all about it.
Thank you. It was my pleasure and a really fun conversation. Thanks for having me.
Thanks again for joining us on the My Climate Journey podcast.
At MCJ Collective, we're all about powering collective innovation for climate solutions by breaking down silos and unleashing problem-solving capacity.
If you'd like to learn more about MCJ Collective, visit us at mcjcollective.com. And if you have a guest suggestion, let us know that via Twitter at mcjpod.
For weekly climate op-eds, jobs, community events, and investment announcements from our MCJ venture funds, be sure to subscribe to our newsletter on our website.
Thanks, and see you next episode.